what is logistic regression? Mostly, even though the name regression is there, but it's a classification model, means it's a classification algorithm. So what is classification? Classification is you are in the output, you are not predicting a continuous value. Instead of that, you predict a class. So what is continuous value? Like the number of years given. If you want to predict the salary of a person, then it's a continuous value. Like you are predicting a number. Whereas here you are predicting a class. What could be? It can be anything, like you have given a pet data set, okay, and you have given the features. This is the ear size, if this is the eye size, okay, if the fur is there, okay, then mostly it would be a dog. So here dog is a class. Likewise, cat is another class. Okay, so that's what you are predicting. You are not predicting a number here. I can give you another example, like the bank data set. Okay, so when the bank wants to know whether, after giving a loan to person, whether that person will default or the person will repay the loan. Okay, so here the classes are two. One is default, another one is repay. Okay, mostly the negative class we denote with 0. That means if you give 0, then it is default, and if it is 1, then the chances are there that the person will repay. So it's the classification. There are other classification modules, algorithms that will go through, like support vector machine, KNN. Okay, but what's the difference? The main difference between those and logistic regression. The logistic regression will produce a probability value for you. Okay, even though it's a class, like what the output is there in the logistic regression, it will try to give you a probability. In the case of the bank, like the person will default or not. Okay, so in that case, it will not give you 0 and 1 directly, it will give you probability. In the first case, suppose for a person of salary 10K, okay, and he with a credit, having a credit card, okay, and all these features, like settling with his own house, so the probability of repayment would be 0.7. Okay, whereas with a salary of 2K and residing in remote area and all, okay, for that person the probability of repayment may be zero point 0.2 or zero point 0.3. So here what we take normally, if any value greater than 0.5, that is 50%, more than 50% probability, then we take it as 1. That means it's a positive thing. Any probability less than 0.5, okay, or 50%, we take it as 0. So manually we have to provide that. After getting the probability in the logistic regression, we have to classify, like if it is point greater than, it depends on your problem statement. Okay, so normally we take 50%. Okay, if you are working with a pharmaceutical industry, suppose for a use case, you are being given the task to oversee the performance of a vaccine. Okay, in that case, you should be sure of more than 90% to give a thumb up, like yes, the vaccine is working. If it is, the probability is less than 90-95%, then you say that normally the output is 0. That means it's a negative output. So there is no hardcore rule that it's, if it is more than 50%, we take it as yes for our class output, or less than 50, it is 0. It depends on your problem statement. So what we'll go through: introduction, logistic regression, what is logistic function, maximum likelihood estimate, logistic regression output, goodness of it. Introduction: there are a set of problems known as classification problems. As the name suggests, the goal here is to predict the correct class of the data. Okay, that I have explained. It's a default or non-default, cat or dog. These are the classes. Examples, will the next flip of the coin will result in a head or tail? Will Russia, win the next FIFA World Cup or not? Is a patient suffering from critical cardiovascular disease or not? Is it a cat or dog in the picture? These are simple two classes. It's called binary classification. Okay, and we are predicting if the certain thing in this class or the class. Okay, so there are two concepts in classification. One is the binary classification. Another one is the n-dimensional classification. Binary means there are two outputs like cat or dog, head or tail, yes or no. When there is more than two classes like yes, probably no, these are three classes. So that is called n-dimensional classification. When it is more than two dimension or two classes, we call it the n-dimensional classification. What are the alternatives? We have learned linear regression so far, where we predict a continuous outcome from a set of x variable. As I explained, in linear regression, giving the years of experience, we can predict the salary of a person. So that is a continuous outcome. Can we apply what we have learned in linear regression for this binary classification? Okay, below is a hypothetical example where I want to predict if a patient has a cardiovascular disease or not when I have their heartbeats or measure. In the chart above, x-axis represents the heartbeat, since we could have two states for the outcome variable. Okay, 0 means no, 1 is okay. What we have learned till this point, the linear regression, like the predicting a number that we are using here, is I explained, if the probability is 100%, okay, in this case they have taken, then it is supposed to be 1, means the output is 1. When there is a probability of 0, then it is the output is 0. That's what it is mentioned here. But in actual sense, none of your models will give you 100% probability for any of the data you want to classify. So that's why we divide. If it is more than 50, okay, this is the line. If you see the yellow line, normally it says if any data points like this, those data points 1, 2, 3, 4, these data points, this part more than 50% line, so it's a yes. These are the less than 50% line, then it's a no. So now let's assume that anything predicted by linear regression, yeah, that's what it is mentioned. Whatever predicted with the linear regression, ever 0.5 classified as a disease patient, the model gives us necessary boundary and the heartbeat around 85. If you see here, these are the number of heartbeats: 50, 110, 170, 230, 290. Okay, so this part, if you see the model saying that whatever the heartbeat, below 85, then it's the patient is not having cardiovascular disease. If it is more, the patient is having a cardiovascular disease. Now, if we happen to get a new case, which is extreme right of the heartbeat, very high heartbeat, then we can classify the patient most likely to have the cardiovascular disease. Okay. The use case is that, suppose you have built a model, whenever the next patient comes, okay, so normally to check the cardiovascular disease, it's a costly affair. You have to spend a lot of money with your scans, X-ray and all. Instead of that, the doctor can check with your heartbeat, and if it is less than 85, then the doctor may confirm that there is no need for further test and you are not having any problem there. And if it is more than 85, then the doctor may suggest you to go for the process like for the test and all, based on this model. Another concept is there, that's called outlier concept in the data. What is outlier? Okay, suppose assume that it's a company of 100 employees. Okay, in this case, like all those people will, from 2k to 10k salary, they will place at one group or one point or over a one range, whereas those three people who are getting 50k, they will be placed far apart from those people. So those persons are called outliers. Okay, they are not belong to the group. That's the outlier concept. In the data basic preprocessing, it requires that you have to take care of those outliers. What you can do, the things like you can drop them while building your model, because those are the outliers, or you can change the values of the outlier to the median value or mean value of the entire data, so that they will fall within the group. What I feel the question could be like, if we change the value, then the entire data set may change. Okay, so whatever the data we have given, we are not predicting to that the accuracy. So these are the problems with the outlier treatment, because you are changing the value. Suppose you, in the salary part, you are changing the value from 50K to your mean value is around 8K. So you are changing the salary of those three persons to 8K, and you are trying to build the model. So obviously there is a loss of information, because actually it's not 8K, it's 50K. It's a loss of information for your model. But yes, it doesn't affect, because your majority in this range. Model will try to give you a value within the, the fair good range from 2K to 10K. Coming to this regression, so in nutshell, the regression line, hence the classification boundary, shifts with the addition deletion of extreme values. Okay, you are not going to predict a correct value. I'm talking about regression. Regression, we are predicting a number, then we are plotting a graph where we see that it's always a 45-degree line. It's not reliable, because linear model predicts unbounded real values. So it could be easily predict values below 0 and above 1. There is no restriction for the linear model, linear regression, because it can predict any value. So 0, 1, less than 0, less than 1. But here, as I explained, in all the classification, either we are going to classify with the 0 and 1, that is the class output, or we are going to get the probability. Again, classify manually, that if the output is more than 0.5, then it is the yes. Okay, and suppose you have given a data set of cat and dog. So you have given a lot of features, pet data, and you want to find is it a dog, the image, or not. And you find that the probability is 0.3 for dog. That means it's not dog, right? Because most of the probability is showing that it's 0.7, that is cat. So like that, we want either a probability output or a class output. Class output is simply you will get 0 and 1. There is no probability. There are two algorithms which will give you the class output that we'll cover in next class, and logistic regression will give you a probability output. So the logistic regression is a statistical modeling technique which provides the conditional probability values for the outcome. It does so using logistic function. What is logistic function? That we'll see next. It's a log function. Little bit mathematical, but I will try to keep it as simple as possible, so that you just remember the concept behind this logistic regression, which is used for classification and which gives a probability output. This curve you see, and understand this curve, because we are going to use it a lot in our deep learning algorithms, everything. It's a very important curve. Okay, we call it as a sigmoid curve. Okay, the name is called sigmoid function. The curve starts from 0. If you see in the y-axis, okay, that is 0, 0.5, 1. The curve ranges from 0 to 1. Okay, so that's what it's called, the sigmoid curve. Why it's 0 to 1 and why we are using in the logistic? Because logistic is a probability output. Second thing, the probability, always you will get a value between 0 and 1. You will not get a value more than 1 or less than 0. Okay, that's why sigmoid curve is a used for the logistic regression. Okay, suppose x-axis is your input -2 and y-axis is 0 to 1. So if you see here in this curve, the -2 is your input, and if you draw a line straight, then you see that it is intersecting the curve at some point which is more than 0. Okay, you are getting probability which is more than 0 but less than 0.5. That's the way of interpreting the sigmoid curve. The name for logistic regression comes from the logistic function. Logistic function is called the sigmoid function, keeps the output value between 0 and 1 as I explained. Logistic function is a probability, so it's a 0 and 1. The output of S-shaped curve, which is more realistic for the binary classification. Why binary classification? Normally, you will get a probability between 0 and 1. So that's why normally used for the binary classification. Whenever you see a sigmoid curve, the sigmoid curve for the binary classification, that is 0 and 1. But only thing, whenever you see the function, then you just remind that this is the function e to the power z divided by 1 plus e to the power z. Mathematical things behind this function, so we won't go to that deep because we require the knowledge to apply it rather than going for the research of with any of the algorithm. The above function satisfies the necessary conditions. Ez ensures the values are always positive. And now to curtail the values below 1, we need a number slightly greater than Ez and divide it by the number. Hence the equation is something something. Okay. Difference between the linear regression line and the sigmoid line. So if you see here, the linear regression line is a straight line. Okay. So in the straight line, what's the range? The range is very small, right? If you place a line here, so this is your coordinate, okay? This is your x, and this is y, suppose. So the linear regression, always you will get a line. It will not be any curve. Either the line is, if it is 0, it is 1, it is 2, 3, 4. Likewise, -1, -2. Okay. So the linear regression, you will always get a line because whatever the x-axis value, x input you will give, you will get a y output. If you plot it, it's a line. So the problem with this line is the range is very small. If you see, the range is from here, okay, to here. Range means what is the x value? This is the range for this function. Okay, this is the what is the x value input it gets, that's the range. So the problem is you will not get a probability with this small range, but instead of that, if it's a sigmoid curve, okay, 0 and 1, suppose you get a curve like this. Okay, suppose it's a S-type curve like this. Now the range has changed from -2 to 4. Actually, for the sigmoid, the range is -4 to +4. Okay. What is the range? That means any value you give between -4 to +4, it is going to produce the output, probability output. That will cover in the deep learning part. But for the time being, you understand that S-shaped curve or the sigmoid curve, because it increases the range. Range has increased, if you see. So any point, if you get a point here, you will get a probability. If you get a point here, you will get more probability. If you point here, you will get less probability. Okay, but here whatever value, if it falls here, then always it's almost fixed. You will not get a probability here. This is again the probability concept, so I will try to explain it light as possible. You will never going to use all this, that sigmoid curve, everything is built there in the Python package. We are interested in probability. As I was telling you from the beginning, the logistic regression is a probability output. It will always give you probability. It will not give you class output. The class output means 0, 1, 2 for the different classes. Okay, cat, dog, okay, horse. So these are the class output. It will not give you, it will give you probability. It's up to you, like how you divide your classes. So we are interested in probability of an event, success, positive diagnosis, etc. given the data. What is the probability? Probability of y equal to 1 given x. Given all the x values, like in the bank data sets, the customer age, the customer income, the customer marital status. Okay, given all these x1, x2, x3, these are the features. Whether the customer is going to repay or not, that is your y. Y is 1. That means the customer will repay given all this. A probability of y equal to 1, this is the function that we have, e to the power z divided by 1 plus e to the power z. Similarly, when it is y equal to 0, you are dividing the entire function with e to the power z. So when you divide the numerator with the same e to the power z, it has become 1. Then 1 divided by e to the power z, and this is the same, right? E to the power z divided by e to the power z, it has 1. So 1 divided by e to the power z is also e to the power z because it's an infinity number. Okay, we can transform the above function into a linear equation using the link function, that is log function. Why it is called logistic? Because if you see, the name itself suggests there is a log, log. Log is called log in mathematics, so it's a log function if you see here. Maximum likelihood estimate, unlike linear regression where the model coefficient are estimated using OLS method. What is that OLS method? The next class I will show you a practical. Okay, so what is the, in linear regression, what is the OLS method? What is the OLS table actually? That I will show you. Logistic regression estimates the coefficients using another model called maximum likelihood estimation. Okay, in layman's term, simply means likelihood of seeing the given sample of data if response variable were to get the value it gets. Okay, we assume that the data comes from a distribution. We estimate the likelihood values of possible betas for the given data. We choose the values betas where the likelihood is maximized. It's again the maths. Okay, there is a beta value included in the maximum likelihood. Wherever it is more than a fixed value, we choose that one. Or in the layman language, you can say it's between 0 to 1, the probability we get the output. Again, this model is in R. So what we'll do, we will keep it for tomorrow, that I will give you hands-on for the logistic regression in the Python. The slide you are seeing now, it is one of the most important slides, okay, of logistic regression, of classification entirely. In the supervised learning part, this slide is most important. First I will explain you, then I will go through the the slide, whatever the lines mentioned. Okay, so if you see, this is called the confusion matrix. Why was the confusion here? If you see, it's a matrix because it comprises of rows and column. What's the confusion here? Confusion is between your 0 and 1. This is the confusion, like whether it's a it's the class is 0 or 1. It's a binary, normally used for the binary classification, because if you see here, the output, if in this above, you see the class predicted by the model, that is the x-axis. This is the model prediction, 1 or 0, and this is the actual data. 1 or 0. So the confusion is whether whatever you have predicted, it's true or not. That's the confusion here. Okay. So this is the confusion matrix. Okay. In confusion matrix, it always, okay. Now suppose it's y, that is the actual data, because it's a level data supervised algorithm. You will be always given the actual data with you. Okay. You have trained your model with the data. Okay. Now you want to test, because as I told you that always you have to divide your data before proceeding with the model creation. Around 70%, 80% of data will go for the training. That means you will give the all the features as well as the output, and the model will train that if given all the features the output is 0, given all the features the output is 1. Like that the model will train itself, and rest 20% of data you will, 10 to 20% of data, the entire data set what you have got it from your customer, you will keep it for the testing purpose. Like what is the model efficiency or accuracy that you need to show to your customers. Okay. So it's the, suppose it's a y, that is the y actual, and we change it to y cap. Okay. It's the predicted value, and the class is 0. That means you have predicted 0 here, negative, you have predicted 1 here. The actual is 0 and 1. Okay. Suppose you have given a customer data set. In the bank data set we will take for our this case study. Okay. Like age. Okay. And the one is income of a person, like that, and you know, use of credit cards. Okay. All this given, whether that person will default or not. That's your y. So actually in the data set you have given the record for first person, second person, like that. For suppose around 1,000 person, 1,000 customers, you have given the data, and you have asked to build a classification model. So here around 70-80% of data, like 800 will go for the training, rest 200 you will keep it for the testing. That will not be given to the model for the training. Okay. So in this testing you already have the data, right? Y data with you, because out of 1,000 you have divided. So that's your y actual, that is the actual data you got it from the customer or the problem statement. That's the y actual. Y hat is, what is y hat? Suppose you mark it here, this is the 800 mark. Okay. These many data from the beginning you have given for the training. Now you are also left with this data, because the entire is 100. From this point to this point you are left the data, that is the entire x features, x1, x2, x3, like that, and the y also with you. So the next part is, after building the model, you will provide only this data to the model, that is x data, that is called x test. X test is this features. Okay. The entire 800 to 1,000 is your x test. You have built a model. Now you will give those x test value and ask the model to predict the y. Okay. That is your y predict. That is model predicts without seeing the actual result. Now you wants to plot it. Okay. That is called confusion matrix. This 0 is actually it's 0. Okay. In your data, that means this y data what you are having, and y hat 0 means the model is also predicted 0. 1 means the model predicted 1. This 1 means actual 1. Okay. The first part is called true negative. Okay. This line is called true negative. Why? Because it's actually 0. it's actually negative, and the model is also predicted negative here. If you see this part, okay, this area, this entire area is called the true negative. Whatever the data point falls here, that is called true negative. Likewise, it's true positive. That means the actually it says that number 950, okay, it's a person's data in this bank data set. The index number 950 is also there because you have given data from 0 to 1000 or 0 to 999. Actual data says the person will repay, that is 1. Your model also predicts that person will repay, that is 1. Then it will fall in this quadrant. Okay, it's a true positive. Likewise, for the 810, suppose 810, okay, suppose 810th index or the 810th number of person, the data, actual data says that the person will not repay, okay, and your model also predicted the data that the person will not repay, then it's called true negative. What's it is true negative, true positive? Truly predicted negative. Okay, the model has truly predicted negative. What is true? If it is same with the actual data, it's called true. So this is true negative, this is true positive. So likewise, it's false positive, FP. Why it is false positive? Falsely predicted positive. Okay, what do you mean by this sentence? Falsely predicted positive? That means actually it's 0. But the model has falsely predicted positive. That's why it's called false positive. It's called false negative. Why? Because the actual is 1. Okay, the actual is true, but the model has predicted the negative because this is 0, right? This entire thing is 0. Whatever the model is predicting from here to here, all are 0. One part is true negative because actually it's 0, but one part is false negative because it's actually 1.